Hello viewers, in this video I'm going to show you how we can actually proceed to this particular problem set on Leetcode. So this is finding all the anagrams in a string. This discussion comes under the topics of hash table, string and sliding window technique. It's sort of a medium level problem. Okay, so let's check this out. So first of all, let's understand what an anagram is. So anagram is something like basically we are given a string. Let's say this string ABC. Let me just take this print brush. Okay, yeah. Cool. So for example, this is a string ABC we are given over there. Uh, what we want to do, if we take all the possible permutations of it, let's say ABC can be converted to ABC, BCA, or CAB. All the possible permutations are called anagrams of a string. What we need to find is, like, given a string to a string S and P, return an array of start index of P anagram and S in S. Okay, so we are given two string. One is a bigger string and another one is a smaller string. What we need to do here is we need to find whether the bigger string S contains what all possible anagrams of B. And what we need to do, we need to return starting index of that particular anagram. So for this instance, let's consider this example number 1. We are given a string ABC. If we check this, what all possible anagrams it can be, it could be ABC, BCA, or CAB. What all, like shuffling of the letters. Okay, so when we check this, what we can do here is, it says that if we proceed by this CBA, this is one possible in which the entire P string is coming here. So we need to output C here. So hence you can check that 0 is given, which is the starting index of this particular anagram. And as soon as we proceed, you can find this ABC, all three letters are occurring again here. So hence this is the sixth occurrence. This is the second occurrence at the sixth index. So the output will be what the number of, like, at the indexes at which the anagrams are present. If we check this example, you can check here this AB string is given and the substring is AB. We need to check like again the same thing, at what indexes these anagrams are appearing. So if we check AB, you can check this at AB is occurring at 0th index, like starting from 0. If we proceed one index further, this is occurring at BA, so again first index, and again if we slide, second index. Okay, so we are going to use a like two pointer approach, or you can say sliding window approach. What we are going to do here is, we will be taking a two pointers, and the length between these two pointers, or you can say the window here is, it's going to be the length of the smaller string. Okay, so in this approach, what we do here is, like, we put first pointer at the beginning of the main substring, and the last pointer, you can say the second pointer, at the length of the substring. Okay, so the length of the substring here is 3. Okay, so we place first pointer at 0 and the second pointer at 2, so that the window size become 3 here. Okay, so first we place the first pointer at 0 and second pointer at this A, which is second index, and then we sort of create a window here, and then we check whether all these, like, letters are the same at this in the or the letter occurring in this particular window. So how we are going to verify here is, we are going to use a hash table kind of thing. So in hash table, what we need to do, you can actually use a list or array kind of thing. So these are letters, so you can say, we know that they are so these are purely letters only. So we can say that, we are having 26 alphabets, so we can create a empty list or empty array containing 26 positions, and we can initially fill them all with 0. Okay, so how we are going to proceed, like, initially one array of 26 position, all 0. As soon as we encounter a letter, let's say C we encountered, we fill the array at the C position. So we are going to having a map A, which is 0, B equal B which is 1, and likewise C, which is 2, D, which is 3, and which represent actually third position. So as soon as we encountered C, we need to like make the position which is the 0 1 2. So the second position in the array we will be making it 1. Likewise, when we encountered B, we will be making the first position in the array as 1, and likewise when we encountered A, we will be making 0th position in the array as 1. Okay, so this that's how we are going to proceed. But as soon as we the window limit is being reached, so यहाँ पे like here the window size is 3. As soon as this window limit of size 3 is being reached, we are going to check the first element, or like the last which is like starting of the index, starting of the window. And then what we are going to do, we are going to check this element. For example, for instance, here we initially encountered C, B, A. We made them all 1 1 1. Like for initially we made C as 1, then B as 1, then A as 1. And as soon as we are moving forward with the E, we need to slide our window by 1 index. So we are going to slide pointer 1 by 1 and pointer 2 by 1. Okay, so as soon as we slide pointer 1 by 1, we are neglecting all of the data behind this pointer. So to neglect this data, we need to reset, not completely, but the reset whatever the data we are having before this. So this is only a single element. So we are going to check what the element is there in pointer 1, what's its index is belong to. So we will be checking like pointer 1 belongs to 0th index. Here in this scenario, in 0th index we are having C. C resembles to 2, like 2 in alphabet position, like A, B, C. So C resembles to 2. So in that hash table, we are going to deduct 1 from its position. Likewise, if we move forward, if instead of E, this is going to be C. If this was C, we are going to increment C by 1. So that's how we are going to proceed. We will be making a hash table, and with each operation we are going to match its hash table with the hash table of the substring. So yes, we need to create a hash table of substring as well. So likewise here we need to create a 26 element empty list, and like we can populate them with the same approach. We will be having 1 1 1 and remaining all 0, which states that A is available one time, B is available one time, C is available one time. Okay, and with each operation we are going to compare, like, is this hash table, or is this list of hash, is this list of mine is equals to the list of the substring or not. So whenever we encounter, yes, these two lists are equal, we can manage a counter. We can, like, yeah, we need to output a list of initial indexes. So what we can do here, we can actually create a list where we will be storing the first pointer of our window. So we'll be putting that index of our window into that particular response list, and then we'll be outputting the response list in the output. Another scenario could be like, if this substring, if the length of the substring increases, like it's greater than the subject. Okay, for example, I need to check this smaller substring into this bigger one, but what if instance in any test case this is bigger than what I need to check. For example, I need to check A, B, C, D, E, F, G, H, I, J, K, L, M and something into this smaller string. Then I can initially straight away return that okay, this is an empty list, you can't check this thing. Okay, so for this purpose you can have a look at this code. I have coded it into Python 3. So the same approach which we just discussed, what we are having here, I have initially declared an empty list, and I initially checked whether the subject in which I need to check is its length is smaller than the substring. Then I am initially returning an empty list which is declared above, and then I am creating a lookup map as we need to look this up, like whether this index resembles to at what position, or this alphabet resemble to at what position. So we are creating a alphabet lookup kind of thing, like A1, B2, C3. We are not going to populate this one. Yeah, so we are not going to populate this alpha lookup dictionary. We are just going to use this as a lookup. Then we are going to create a hash list as discussed, where we are initially making all the elements as a zero, and likewise we are going to create a hash list of the subject where we need to check. So I've just created a copy of it. Yep. Moving further, we are having we are going to loop into this particular list, which is a substring of it. So we are going to create an initial hash map where we are going to check, like we are going to create an initial hash map in which we are going to having a lookup, or we are going to match it every instance when we are altering our s hash letter. So we populated it. So for this instance we are going to have a, b and c. This populates this p hash list as 1 1 1 and remaining all is 0. We initialize our two pointers, first pointer at 0th index, second pointer at the last index means the length of the smallest string, um, which is position which is length of 3. So first pointer will be pointing at 0th index, and the third second last and the second pointer will be pointing at the length of the substring, which is 3 here. So it is going to point at 2, so that the length of the window becomes the length of the substring here. So 0 1 2 it becomes 3, likewise here. Okay, and then we proceed here. We are going to check this first. We are going to iterate over this bigger string. We are going to check this c occurs here. We will be checking what's the index according to this alphabet lookup, and then we are going to increment that value. Then c occurs. C is actually 0 1 2, so c resembles to 2 position. In this s hash list we will be making the element at the second index and incrementing it at by 1. Okay, so likewise we are going to proceed. This for loop will only populate the range of 0 to length of the your smallest string. Why we are going to do this is just to populate the initial iteration, so that these 3 iterations can be done. Okay, 3 in this case, but in other case it could be the length of the smallest substring. Once we are having initial population of the list is done, we are going to like populate the other available elements, which starts from the remaining part, that is the end of the last previous sub window. So here we are having p2, and p2 is the second pointer, which is initially we left at length of the smaller substring. We left it at the second index, and then as we proceeded we check, okay, so this is e, and then e resembles to, that's 0 1 2 3 4, fourth position. We yeah, but before checking that out, we need, as we discussed, that we are sliding the window. So in order to slide we need to move both the pointers by one position. So to move pointer 1 by one position, we need to deduct the value of its previous pointer holding. For example, we are having a b c, and as we move the pointer to b a e, we are having pointer to at position e, but we need to forget what all the possible values we are holding before it. So we need to delete the effect of c from the s hash list. So how we are going to do, we are going to check what value p1 pointer holds. So p1 holds here 0. From 0 we are going to check in s p1 what resembles it to. So it says 0 position resembles to c, and then we are going to look up in the alphabet lookup. So c resembles to second position in the s map s hash list. So in s hash we are going to deduct c value by 1. Okay, and the remaining part remains the same as this for loop. Like we are moving the window by 1, then we are incrementing p2 pointer by 1 in each iteration, and then we are going to update this s hash list. And with each iteration we are going to check whether my s hash is going to be equal as p hash or not. If they are equal, we are going to append this response list which we initially declare as empty, and then we are going to increment the pointer one position into it, and at the end of this while loop we are incrementing pointer 2. And just do remember, while performing this deletion operation from the sh list, we are incrementing pointer 1 after this. Okay, so as you are sliding your window CBA, you slide it to BAE, you are incrementing pointer 2 by 1, and you are decrementing, like you are incrementing pointer 1 as well, but what all values you are holding before it, you need to decrement their values in s hash list. Okay, so C holds one position, but we need to deduct its value by 1. So how we are going to do, we are checking, you can either have another variable here, like your p1, what p1 holds, so that you don't need to do this thing. But what I'm doing here is I'm just checking what value C holds, this pointer one upholds, so it is giving me C. From C I am just again looking up into this alpha lookup. It says that C resembles to second position, and in s hash I am deducting as second position by 1. So yep, that's it. If you submit it, so let's run it. I actually submitted before, so these are the possible. So I have this is a custom test case. Let me reset it. So this submit thing. Okay, so this is submitted, and yep. So this is the one. I feel it's the thing. Yeah. So these are all the stats for it. Thanks. Yeah, thank you for watching.